Hi, it's Dave Parody of FinancialViz.com and ThinkOutsideTheSlide.com. Today I want to talk about a problem that I see regularly when I'm doing makeovers for my customized Financial Viz training courses. And it's this footnote you see on this table or this graph here that says values don't add to 100% due to rounding. This is something that is common, and my concern with putting that footnote on is that you are indicating to your viewer, hey, you know what? I don't know how I get these numbers to add up to 100%. And if you don't put the footnote on and they notice, it's even worse because now they're starting to go, what? You don't even know how to get these numbers to add up to 100%. What else in your analysis, your financial results, should I not trust if you can't even get these numbers to add up to 100%? Well, a lot of people struggle with this because they say, but Dave, look, the numbers are here. This is the percentages that got calculated from Excel. And if you add them up, I'll just highlight them here. We'll go down to the bottom and zoom in how Excel tells us what's the sum. Indeed, 102%. So it doesn't add to 100%. So why does this happen? And in the video, I want to show you some different ways to solve this problem so that the numbers always add up to 100% and you never need that footnote. So now I've scrolled up in the worksheet in Excel, and here's the data that we had come in. Our different A through I, and then the values here. And I calculated the percentages, simple calculation here, take the value divided by the sum, which is down at the bottom there. Very simple, and of course, it goes to however many decimal places you want to display. So the challenge is when we set the display units, the display decimal places in Excel to 0 for percentages, this is what it shows. Now, when you look at the sum down at the bottom here, this is just the sum of those cells. You go, well, it adds up to 100%. No, it doesn't. What it's doing is it's adding all of the numbers, but it's not adding the numbers you see. It's adding the numbers behind that one with all the decimal places. Of course, they add up to 100%. When we do the true, instead of display 0, round 0, so in this case, let me show you the formula here. Very simple, round that value to 2 decimal places. Why 2 decimal places? Because again, percentages are by default 2 decimal places. So we have to remember that when we're doing these calculations. So when we say round 0, it gives us those exact same numbers as the display 0. But now when we add it up at the bottom, look, here's the 102%. This is why people say, well, the rounding, Dave, it doesn't allow me to add it to 100%. But it should. It should always add to 100% so that we're giving a true picture to our viewers and they can trust the numbers that we're showing. So the question is, how can we solve this? And is this something that is inevitable? No, it's not inevitable. We can and should solve this issue. Now, is the solution to the issue manually changing things? Not necessarily, but first I want to show you Excel never has this issue. And you go, well, why do I have the issue? And why are you saying Excel never has the issue, Dave? Well, let me show you why Excel never has this issue if you create the chart a certain way. So this chart is created here. You'll notice I use the A through I and I use the percent that comes from the round 0. But if you create this chart using the values instead, you get a different result. So let me highlight these cells here. Say insert a regular pie chart, and I'm just going to move this over here and make it different size. Okay, and I'm going to get rid of the title and the legend, and I'm going to add the data labels. So I'm going to have to go to more options here because I want to show you what I'm going to add. So let me zoom in here. And I'm going to add the category name, which is the A through I. And instead of the value, I'm going to add the percentage. I'm going to release the value. I'm going to separate it instead of by a comma. I'm going to separate it just with a space. And I'm going to place them outside so that we can see them. Now, let's take a look at our values. We've got A is 25, B is 22, C here is 17, not 18. And the other change is in E, which is 5, not 6. Why? Because Excel always makes sure that its percentages add up to 100%. Because this is a pie chart that adds to 100%. When you add the percentage labels, it calculates it. Now, why did it calculate it differently than it seemed to calculate it in the cells? Because Excel is adjusting the rounded values. It's adjusting those rounded values that got rounded up the most and says, hey, you know what, we're going to have to adjust it so that it adds up to 100%. This is kind of the model we want to think about, is to say we always want ours to add to 100%. So let's take a look at some different ways to solve this problem. Solution number one is to increase the number of decimal places we're using to show the percentage. So, for example, instead of rounding to 0 decimal places, if I rounded to 2 decimal places, then it would add up to 100% exactly. Now, sometimes you have to go to 3, sometimes you can use only 1. But if I rounded this, instead of rounding it to 2 here, I'm going to say round to 4. And then I'm going to copy that down. And if I look at this 100%, let me give you another decimal place there. See, it's exactly 100%. Now, that's certainly a solution to this, but we don't always want to use that solution because sometimes that's too many characters in the table or on the chart. It looks too busy. So while that is a solution, it's not likely the solution that a lot of people are going to select. Our second solution is a manual adjustment. So the manual adjustment says we take a look at our column here and say, okay, which ones should change? Well, let's see here. Well, 17.5 rounded to 18. Well, you know, if we have to get rid of 2%, that's probably one where I'm going to, okay, I'll adjust that to 17%. And then this one here, 5.5. Okay, so I'll change that to 5%. Hey, now it adds up to 100%. I've solved the problem. But I've actually introduced a bigger issue. A bigger issue because now these cells, the ones that I changed manually, are not formulas anymore. And when the data comes in for next month and I put it in here, these values are not going to update because they're now typed in. They're not formulas. So while this is possible, it requires manual intervention potentially every single time. And it gives the opportunity for the wrong number to be there, the wrong number to be used. And of course, unfortunately, we find this out only when it's in front of our boss. So the second solution is a manual solution, but it does have significant risks with it. And it's why I would not suggest you use that manual solution. The third solution is where we want to simulate the idea that Excel is using. So Excel is using the idea that we manually just showed in that second solution to say, look at the ones that got rounded up but could get rounded down, and it's not that much of a stretch, and adjust those. But we want to do it in a way that's automated. And this set of columns here, H through K, is the solution that I want to talk about. So in H4 here, what I'm doing is I'm introducing how many decimals do I want this column to be rounded to. So I'm going to use 4. And what you need to do is you need to use a number where when you do the sum down at the bottom here, it's exactly 100%. So you want to find as many decimal places as you need to make sure that it's going to be exactly 100%. I tried 3, it didn't give me that. I had to go to 4. So now I've got perfect 100%. Then column I, we round it to 2 decimal places. This is the number of decimal places we actually want it to be. We don't want any decimals after the percentage. Remembering again, percentages are 2 decimal places to start with. These are parameters. H4 and I4 are parameters so that we can change them as needed. So the formulas here, when we take a look at the formula for this particular cell, it says round the value in the number of decimals, use that value in H4. I am really big on making as many things as you can in your calculations parameters so that you adjust one thing and everything else changes. Now, I've got my perfect 100% and I've got the one that I want. Now I need to figure out, where do I need to adjust it? So the first thing I do is I look at the total. Is it higher than 100% or lower than 100%? And I set this direction. So my direction input is an H or an L, H being the total is higher, so I know I need to reduce it. If it's L, then it's lower and I need to increase it. So then I have two other inputs. The first one here is the factor. So the factor is by how much should I be checking the difference between the rounding that gives me 100% totally and the rounding that I get where I've got my problem. This is really generally going to be less than 0.5%, because in rounding, if you're especially going to rounding for a full percentage point, it's going to be half of that lowest number. So if 1% is the lowest, half of that or less. 0.4, I usually don't want to go to 0.5 because that's too close to the border. So I'll go to 0.4. And then and again, this is a parameter, so you can adjust it as needed. And we'll see that when I give you another example here. And then the adjustment amount. So if the value needs to be adjusted, by how much should it be adjusted? Because we're doing full percentages here, it's 1 full percentage point. We'll see in the next example where we're going to do it, and it's going to be smaller than that. So now we've got our parameters, and we can do our adjustments. So let me take a look at, in a little more detail, the formula here for this adjusted rounded value. And so it starts out and it says, okay, so if the difference between I8 and H8, and it's the absolute difference because, again, it could be positive or negative depending on whether it's higher or lower in the total. If that's greater than K4, that was that parameter that said, here's the factor that we want it to be greater than. If that's the case, then this is a candidate that we want to change. We want to adjust the rounded value here. So if K3 is H, meaning the total was higher, then we subtract the adjustment from the value. If it's not, then it must have been lower, so we add on that adjustment. And if we don't need to make an adjustment at all because the difference wasn't above the factor, then we just use the value as it was. So we use this formula, again, driven by these parameters, to be able to adjust our rounded values. And indeed, we'll notice here, it adjusted this value because the difference between 18 and 17.51 is greater than our 0.4. And the other one it adjusted was here because the difference between 6 and 5.51 was, again, greater than our 0.4. And when we add these numbers up, we get to the perfect 100%. So these are the adjusted rounded values that we want to use. Setting up a table this way allows you to make these adjustments depending on how many decimal places you want. So let me show you another example. So here's an example of where I've rounded our values to 1 decimal place. And you'll notice this adds up not to 100%, it's below 100%, 99.9%. So now, when I take a look at, okay, if this is what I wanted, how would I adjust it? I still have the same decimal rounding for the exact 100%. Here, my factor here is not going to be rounded to 2 decimal places, but to 3 decimal places. So we'll type 3 in there. And we'll notice, you notice that says 99.9. Now, why didn't adjust anything? Well, because now our factor has to be smaller than 0.4%. It has to be 0.04%. Because again, we're going to that next decimal place. So I'll put in 0.04%. And our adjustment in amount is not 1%, it's 0.1%. And nothing changed. Well, this is a good example of where the factor, in this case, is still a little too large. So now we would want to say, okay, what should our factor be? Let's go a little smaller. Let's say 0.035%. And we have to increase our decimal so we can see it. That went the wrong direction. Well, why did it go the wrong direction? Because I didn't set the direction. So L, and now there we go. So Remember, set the direction. I hadn't changed that, my mistake. But good that you saw that, because when it moves the opposite direction, that gives you an indication, hey, I'm moving it in the wrong way. So I adjusted it from 0.04% to 0.035%, and indeed now I get exactly the 100% that I want. And which one did it change? It changed this one here. It changed because the difference between 3.8 and 3.84, that's where the factor now adjusted. That one value, all the other ones stayed the same. So when we set up this sort of a table, we can make sure that the values that we are calculating actually add up to 100%. And so this is what we want to do when we are presenting information in a table or in a chart, pie chart, where we're showing these percentages. We want to calculate the percentages, and we want to never have to put that footnote on that says, oh, gee, the values don't add up to 100% because of rounding. No, that's our responsibility as the presenter of this data to our executives and to other audiences to make sure that the numbers are accurate and they add up to 100%, which is what they're supposed to add up to. So I think this third solution is a really flexible solution and one that you can use regularly, and it really thinks about it the same way Excel does when it calculated its percentages for that pie chart. Our fourth solution actually uses Excel to give us the numbers. So we know from Excel it will give us a pie chart that has the correct numbers, the way we want them to be. We can leverage Excel's ability to actually look at a picture of numbers and figure out what the numbers are. So we create a pie chart like I've done here, where I used again, this pie chart uses the values, and I added the data labels that were the percentages. Now, when you add the data labels as percentages, each of these data labels has, in my case, I have the category name and the percentage. What I want to do is I want to create a column on the right side of this pie chart with all of the numbers in it. Then I want to take those numbers and put them into Excel as if I had typed them. Here's how I'm going to do that. So I've set my pie chart up. I'm going to select each data label individually. So I click first, select all of them. Click a second time, I select just this one. See how the circles changed? Now I want to make sure my cursor has that 4-arrow cursor. And I'll zoom in there so you can see that. See how that has the 4-arrow cursor? And that's going to allow me to move this data label up and start my column of data labels. And I leave the leader lines on for now. Why? Because I want to make sure I get these in the correct order. Now, I have taken this data from a client example. Obviously, I've anonymized it by just using A through I, so you don't know what these values represented. But in your case, you're going to have longer text. You want to make sure it's in the correct order. So now I'm going to select each of these, and I'm going to bring them up to that particular spot. So I'm creating a column. Now, is it a perfect column? No, it doesn't need to be perfectly aligned, but it needs to be pretty good alignment here. So I'm just going to do each of these. And 2 more. There we go. Okay, so now what I want to do is I want to select all of the data labels and go into my data label additional formatting, my more options here, and say, okay, I don't want the leader lines and I don't want the category name, because all I want is I just want that column of numbers. That's what I want. That's what I need. Okay. Now, make sure I haven't selected those so there's nothing else around them. Now what I'm going to do is I'm going to take a screen capture of just that column of numbers. And in Windows, I'm going to use Windows Shift S. And you'll notice my screen goes gray, and I have my selection cursor here. I'm going to draw a rectangle around those numbers and release it. Now what this has done is it's copied that screen capture to the clipboard. That's where it copied it. So now what I can do is I can go to a cell here, any cell wherever you want this column to be input. And then I'm going to go to the data ribbon. And on the data ribbon, I'll zoom in so you can see this here. I'm going to say from picture, and I'm going to say picture from clipboard. Now, if there's no picture on the clipboard, this is grayed out, which makes a lot of sense, right? So I'm going to click on this. And what you're going to see is it says we're analyzing your image. It's analyzed the image, and then down below here, it shows you, here's what we saw in that image. And no surprise, it's pretty easy for it to interpret that particular data because it's pretty much in a column and it's easy numbers, percentages. So now I'm going to click Insert Data, and it warns you, says, hey, you're responsible to make sure this is accurate. Yep, got that. Insert it. Go ahead. And you'll notice now what it's done is it has inserted that column of numbers as if I had typed them in. Now I have exactly the numbers that Excel calculated for those percentages, doing its adjustments the way it did it. So this is a fourth solution. It's a much more involved solution. I get that. Totally understand. That's a much more involved solution. But I wanted to show it to you because it leverages this feature within PowerPoint on that data ribbon to say, insert the data from a picture that's on the clipboard. So it's a great option to consider when you are wanting to get the data in. Accuracy of the data we present does matter. When we put footnotes on that say numbers don't add up to what they're supposed to, we give or introduce doubt into the mind of the viewer. So use the solutions I have shared with you in this video to make sure that the numbers you calculate, the percentages always add up to 100%. Make the adjustments using one of the solutions that I've shown you to make sure that when you present a chart or you present a pie chart, table of numbers, those percentages will always add to 100%, and you will never again have to put that footnote on saying values don't add up to 100% because of rounding. This is the type of advanced topics and techniques that I share in my Financial Viz courses. These customized training courses take the data that my clients work with and show them how to create effective visuals that communicate the messages clearly to executives and other stakeholders. If this is of interest to you, go to my website at financialviz.com, learn more about the courses, get in touch, and we can set up a customized course for you and your colleagues.